Tonight, we're going to talk about the fact that every world we have ever looked at closely is dead. Not empty, dead. There is a difference, and the difference is the whole of tonight. Mars had rivers. You can still see the channels from orbit, cut into the rock by water that ran for hundreds of millions of years. It had a thicker atmosphere. It had a magnetic field. All three are gone now, and it is the nearest world to this one. Venus is almost exactly the size of Earth. There is good reason to think it had oceans, possibly for billions of years. Today, the surface is hot enough to melt lead. Two neighbors, both of them probably had water on the surface. Both of them lost it in completely different ways, and neither is coming back. Nothing lives on either one, as far as anybody can tell. Nothing lives on the Moon, or on Mercury, or on any of the roughly 300 other moons in this solar system that anybody has managed to examine. One world out of every world we have ever checked has anything alive on it, and you are standing on it. So here is the question tonight is about. If this happened everywhere, if worlds get their chance and lose it, then the reason nobody has ever answered us is not that the universe is empty. It is that something reliably ends things before they get old enough to be heard. That whatever it is has already happened to everybody else, and that we might be the only ones left. I want to be careful with that idea, because it gets stated with far more confidence than the evidence supports, and a good part of tonight is spent on the reasons it might be wrong. But it is not a fringe position, and the people who take it most seriously are not the ones you would expect. By the end, you'll know how many worlds have died, what almost certainly killed them, and why finding life on Mars would be the worst news this species has ever received. Tonight comes in pieces, and each one stands on its own. If you drift off partway through, nothing later depends on what you missed. Start with Mars, because it is the closest, and because it is the one we have walked on with machines. 4 billion years ago, Mars was not the place it is now. There was water on the surface, and not in traces. There were rivers with tributaries, standing lakes, and a shoreline that some researchers argue was an ocean covering much of the northern hemisphere. The evidence is not subtle, and it is not inferred from chemistry. It is the shape of the ground. There are valley networks that branch the way river systems branch on Earth, because water flowing downhill does the same thing everywhere. There are deltas where a river slowed as it entered standing water and dropped what it was carrying. A rover has been driving across one of them for the last 5 years. There are rounded pebbles, which is what happens to rock that has been tumbled along a riverbed for a long time. There are minerals that only form in water and stay formed for billions of years afterward, sitting in the open. So Mars had weather. It had a water cycle. It rained there. One thing first. If you want more nights like this, subscribe. That's all I'll ask. Back to it. Then it stopped. And the reason it stopped is the part that matters tonight. Mars is about half the width of Earth and roughly 1/10 of the mass. Small planets cool faster because heat escapes through the surface, and a smaller body has more surface for the amount of interior it is trying to keep warm. Deep inside this planet, there is molten metal in motion, and that motion generates a magnetic field that reaches out past the atmosphere and wraps the whole world. Mars had one of those too. There are rocks on the Martian surface that were magnetized when they cooled, and they are pointed in directions that only make sense if there was a global field at the time. Then the interior cooled enough that the motion stopped, somewhere around 4 billion years ago, and the field went with it. What that field had been doing was holding the air on. The sun emits a constant stream of charged particles in every direction. When those particles hit an atmosphere with no magnetic field in front of it, they knock molecules off the top of it, one at a time, permanently. A world losing air this way does not lose it in a catastrophe. It loses it at a rate you could not notice in a human lifetime, for 1 billion years. The thinner the air gets, the lower the pressure, and below a certain pressure liquid water cannot stay liquid at all. It goes straight from ice to vapor, and the vapor goes where the rest of the air went. That is what killed Mars. Not an impact, not an explosion. It got cold in the middle, lost its magnetic field, and then the sun took the atmosphere away over an unimaginably long stretch of time. What is left is worth stating plainly, because the before and after is the entire point. The average temperature on the surface of Mars is around -80 degrees Fahrenheit. The air is about 1% as thick as the air where you are. There is no liquid water anywhere on the surface, and there cannot be. The ground is exposed to radiation that would be lethal over time, because there is no magnetic field and almost no atmosphere to absorb it. There is still water there. It is frozen at the poles and mixed into the soil as ice. The world did not lose its water so much as lose the ability to keep it liquid. A planet with rivers became a planet with permafrost and dust, and it did it slowly, and there was nothing anybody could have done about it. Now Venus, which died in the opposite direction and is stranger for it. Venus is the same size as Earth to within about 5%, same rough composition, formed at the same time out of the same material, slightly closer to the Sun. There is serious work arguing that Venus had liquid water on its surface for 2 to 3 billion years. Some models put it as habitable for longer than Mars ever was. What happened there is a feedback that runs one way and does not stop. The sun gets brighter as it ages. Slowly, but it does. At some point, Venus received enough heat that its oceans began evaporating faster than they could return. Water vapor in an atmosphere traps heat, so the more that evaporated, the hotter it got, and the hotter it got, the more evaporated. There is no natural point where that process turns around. Eventually, the oceans were entirely in the air. Sunlight broke those water molecules apart high in the atmosphere, and the hydrogen, being extremely light, escaped to space. Once the hydrogen is gone, the water can never be reassembled. It is not stored anywhere. It is simply no longer on the planet. What is left is a surface at about 870 degrees Fahrenheit, hot enough to melt lead. The pressure is roughly 90 times what you are under right now, which is what you would experience about half a mile down in the ocean. Clouds of sulfuric acid, no water at all. The Soviet Union landed several probes there in the 1970s and 80s. The longest one survived on the surface for about 2 hours before it stopped. Everything humans have ever put on Venus has been destroyed by Venus. So the two worlds either side of us both had water, and one froze and one boiled, and both of them are permanent. Then the rest, and the moon deserves a moment on its own, because it is the only other world anybody has stood on. There is no air there at all, not thin air, none. The pressure at the surface is close to what you would find in the space between planets. That has a consequence people rarely think through. With no air there is no weather. Nothing blows, nothing rains, nothing erodes. The footprints left there in the late 1960s and early 70s are still exactly where they were put. Not approximately, exactly. The edges are as sharp as the moment they were pressed into the dust, and they will stay that way for millions of years, because there is nothing on that world capable of disturbing them except the occasional micrometeorite. 12 people have walked on another world, and their footprints will outlast every structure ever built on this one. The temperature there swings by around 500 degrees between the lit surface and the shadowed one, because with no air there is nothing to carry heat from one to the other. Step from sunlight into shade, and you are crossing that entire range in a stride. It is the closest world to us. It is the only one anybody has touched, and it is as dead as a place can be. Mercury is similar and worse. Essentially no air, and a surface that swings by more than 1,000 degrees between day and night. Jupiter, Saturn, Uranus and Neptune have no surface to stand on in any meaningful sense. They are deep atmospheres over strange interiors, and the pressure at any depth you might call a surface would crush anything. Titan, the largest moon of Saturn, is the only other world in this system with liquid standing on its surface, and it deserves more than a passing mention because of how nearly familiar it is. It has a thick atmosphere, thicker than the one here, mostly nitrogen, the same as the one you are breathing. It has clouds, it rains there, and the rain falls slowly through the heavy air. There are rivers with tributaries, there are lakes with shorelines, and seas large enough to have their own names. None of it is water. At around -290 degrees Fahrenheit, water on Titan is not a liquid, it is bedrock. The mountains there are made of ice, and ice at that temperature is as hard as stone. What flows instead is methane and ethane, which on this world are gases, and there are liquids. So the rivers are running with the stuff we pipe into houses to burn, and the rain that fills them is the same, falling out of an orange sky onto ground made of frozen water. A probe landed there in 2005 and sent back pictures for about 90 minutes before the cold took it. What they show is a flat plain scattered with rounded pebbles of ice, smoothed by liquid that ran over them. It is the only place besides here where anything has ever been photographed lying on a surface shaped by flowing liquid, and nothing lives in it, as far as anybody can tell. It is a world with weather and rivers and shorelines and seasons, and it is empty. There are two places left in this solar system where the question is genuinely open, and both are under ice. Europa, a moon of Jupiter, has an ocean of liquid salt water beneath a shell of ice several miles thick. There is more water in it than in every ocean on Earth combined. Enceladus, a small moon of Saturn, has another one, and it is venting that ocean into space through cracks at its south pole. Nobody knows what is in either of them. Nobody has been able to look properly. So the count, honestly stated, is this: 8 planets, something like 300 moons. One of them has anything alive on it, 2 of them have not been checked, and every single other one is dead. That is our own solar system, and it is the only one we can examine closely. And the strangest part is not that they are dead, it is that 2 of them almost certainly were not, once, and the difference between them and us came down to the size of a planet's core and the distance to a star. On July 21st of 2024, a rover called Perseverance rolled up to a rock in a dried-out riverbed on Mars, and what it found there is the strangest problem in this entire subject. The rock was named Shiava Falls. It sits in a crater that used to be a lake with a river running into it. 3 things showed up in it together, clear signs that water had run through the rock, carbon bonded into the kinds of molecules living things are built from, and dark and light markings across the surface, described as leopard spots, of a kind that on this planet is made mostly by microbes pulling energy out of minerals. Any one of those alone would be mildly interesting. All 3 in the same rock, in an ancient riverbed, is why NASA announced in September of 2025 that this is one of the strongest possible signs of past life ever found on Mars. Possible. That word is doing careful work, and everybody involved has been honest about it. The markings could have been made by something alive. They could also have been made by chemistry with nothing alive anywhere near it. Telling those apart needs the rock in a laboratory here. Perseverance cut a piece of it out, sealed it in a metal tube, and left the tube sitting on the surface of Mars, which is exactly what it was built to do. And then the strange part, which has nothing to do with science. The mission to go and collect those tubes has been running badly over budget for years and has been proposed for cancellation. The sample that might answer the largest question anybody has ever asked is lying in a tube on another planet, and the argument about whether to go and get it is an argument about money. There has been public discussion of whether another country might go and retrieve it instead. I find that bleakly funny, and I also think it is worth sitting with, because it tells you something true. The romantic version has our whole species straining toward the answer. The real version has a tube on a rock and a budget line. Now the part that inverts everything. If we go and get that tube, and it turns out those markings were made by something that was alive, that would be the worst news the human species has ever received. Not the best, the worst. The argument is short, and it is very hard to escape once you have followed it. Something in the long chain between a dead rock and a species that can build a rover has to be nearly impossible. We know that because the sky is quiet and the galaxy is old and full of planets. Somewhere in that chain there is a wall that almost nothing gets past. The comforting version is that the wall is behind us, that the hard part already happened, we got improbably lucky, and everything ahead is open. Now find life on Mars that started separately from ours. 2 worlds, same star. Life began on both. independently. If it happened here twice, then starting life is not the wall. It is easy. It is simply what happens when the conditions are met, and the conditions get met everywhere, because there is nothing special about this star, and there are a couple 100 billion others in this galaxy alone. And if starting is easy, and the sky is still silent, then the wall is somewhere else in the chain. Further along than where we are standing right now. That is the whole thing. Every early step you discover is easy, pushes the wall forward, toward us, and eventually past us. A philosopher named Nick Bostrom wrote this up in 2008 in an essay with a title that says everything. He hoped the search for life beyond Earth would find nothing, not because he wanted the universe to be empty, because the alternative is worse. There is one condition on all of this, and it matters enormously. The Mars life would have to be a genuinely separate beginning. Mars and Earth trade material, impacts blast rock off one, and some of it eventually lands on the other, and microbes can survive that trip. There are Martian rocks in collections here that arrived exactly that way. So if something is found on Mars, and it is built the same way we are, from the same components in the same arrangements, the simplest explanation is not two beginnings, it is one beginning and a delivery service. Either life started here and was thrown over there, or it started there and was thrown here, and everything alive on both worlds is one family. That would be an extraordinary discovery, and it would tell us nothing about the wall. What would matter is finding something built differently, something that clearly did not descend from anything we are related to. And it gets worse the more complicated the thing you find is. Simple microbes on Mars would be bad, because it takes the beginning of life off the list of candidates for the wall. Anything with internal structure, anything that had started to get complicated, would be considerably worse, because that takes the best remaining candidate off the list too. Evidence of anything genuinely complex would be close to catastrophic for the hopeful reading, because at that point nearly every early step is demonstrated to be repeatable, and there is very little chain left between there and us for a wall to hide in. Every rung you find occupied is a rung that is not the wall, and the wall has to be somewhere. It is worth sitting with what a wall in front of us would actually mean, because it is easy to hear that phrase and not take it in. It would mean that every civilization that has ever reached roughly where we are has stopped, not some of them, effectively all of them, across billions of years and hundreds of billions of stars, with no exceptions that anybody can detect. That is a very strong claim, and it has an uncomfortable property. It would apply to us for the same reason it applied to them. Whatever it is would not be something we could see coming, because none of them saw it coming either, or if they did, it made no difference. And the candidates people raise are the obvious ones. Weapons capable of ending everything. Damage to a planet's systems faster than the ability to repair it. Engineered organisms. Machines that get away from their makers. Or something nobody has thought of, which is probably the category that should worry anybody most, because we are the only example available, and we have been technological for about a century. Notice what all of those have in common, because it is the thing to check every time somebody offers you one. There is no evidence for any of them. Not one has ever been observed happening to anybody. They are inferred entirely from the absence of signals, which means the reasoning runs in a circle. The sky is empty, therefore something kills everyone, and we know something kills everyone because the sky is empty. Compare that with the case for a wall behind us, which rests on the fossil record, on genetics, on the single origin of the complex cell, and on how late we turned up in this world's habitable window. Those are things somebody went and checked. Imperfect, from a sample of one, but checked. So on the evidence available today, the wall being behind us is the better supported position, and it is also the more comfortable one, which is a coincidence worth being suspicious of, and which does not make it wrong. Mars is not the only place this applies, and this is where the two ice moons come back. Europa has an ocean of salt water under its ice with more water in it than every ocean on Earth combined. Enceladus has another one, and it is spraying that ocean into space through cracks at its south pole, which means samples of it are available to anybody who flies through the plume. A spacecraft did exactly that. What came back was water, salts, the building blocks of life, and grains of a kind that on this planet only form where hot water meets rock on an ocean floor. Later work found a usable energy source in there, and then phosphorus, which is the one element life cannot manage without, and which had been the missing item on the list. So there is a small moon with a liquid ocean, hot rock at the bottom, the right chemistry, an energy supply, and every essential element, throwing samples of itself into space for free. Nobody has been back to Enceladus with the right equipment. That is a scheduling and funding problem rather than a scientific one. Europa is a different story, and there is a date attached to it that is worth holding. In October of 2024, a spacecraft left this planet aimed at that moon. It is the largest thing ever sent to the outer solar system, and it is carrying equipment specifically designed to work out what is under the ice, how thick the shell is, how deep the ocean goes, what the water is made of, and whether anything is coming up through the cracks. It arrives in 2030. A second one, launched by Europe the year before, arrives around 2031 and will look at Ganymede and Callisto as well, 2 more moons with suspected oceans of their own. So this is not a question waiting on somebody to decide it matters. The machines are already in flight. If you are listening to this in the year it was made, the answer to whether there is a second habitable place in this solar system is roughly 5 years out. Neither of them will find life. That is worth being clear about. They are not landing, they are not drilling, and neither carries anything capable of detecting an organism. What they will do is establish whether the conditions down there are right, in enough detail that somebody can decide whether it is worth building the thing that would go and look properly, which would be another 20 years after that at least. That is the actual pace of this. The tube on Mars has been waiting since 2024. The Europa answer arrives around 2030. Anything conclusive about what lives in either place is a job for people who are children now. You will very likely find out whether Europa's ocean could support life. You may well not find out whether it does. 3 independent chances in one solar system then. Not one world with a lottery ticket. 4 candidate places around a single ordinary star. If any of them turns out to be occupied by something that started on its own, the same argument fires. There is a complication attached to all of it that may end up mattering more than anything else here. We might ruin the answer before we get it. Spacecraft are cleaned before launch, aggressively, under international agreements written for exactly this reason. They are not sterile. Nothing built on a world covered in microbes is ever fully sterile, and some bacterial spores survive heat and vacuum and radiation remarkably well. Every lander ever sent to Mars has carried some quantity of Earth life with it. The rules exist to keep that quantity low enough that it will not take hold. You are carrying more microbes on your hands right now than a spacecraft is allowed to launch with across its entire surface, which tells you both how seriously the cleaning is taken and how impossible perfection is. If it ever fails, and something we brought establishes itself, then the most important question available to this species becomes permanently unanswerable. Anything found afterward would have to be checked against our own catalogue, and the doubt might never lift. That is a slightly absurd way to lose an answer, not to distance or cost or physics, to insufficient cleaning. So the position this leaves you in is uncomfortable, and it inverts how most people feel about the question. Every mission going out there is looking for life. That is the stated goal. It is what the funding is for, and finding it would be the most celebrated result in history. There would be a week of coverage, and people would remember where they were. And the reasoning above says the correct response to that news would be a very specific kind of dread. I want to be honest about how much weight this argument carries, because I have just spent a while making it sound airtight, and it is not. It depends on the idea of a single wall being the right way to think about the problem, which is an interpretation rather than something anybody has measured. And it assumes the chain of steps is the right model at all, when biology rarely arranges itself in neat sequences. There is also a completely different explanation that requires no wall anywhere, nothing waiting for us, and nobody dead. Several serious people hold it, and it is coming later tonight. But if you take the framework seriously, and a lot of thoughtful people do, then it produces one of the few genuinely counterintuitive conclusions in all of science. We are spending billions of dollars searching for something that, if we find it, should frighten us. And the reason to take it seriously is sitting in the fossil record of this planet, where something happened exactly once in 4 billion years and never happened again. Around 2 billion years ago, one cell ended up inside another cell and they did not kill each other, and every plant and animal and fungus that has ever existed descends from that single moment. It happened once. As far as anybody can tell, in 4 billion years of life on this planet, in an environment absolutely saturated with living things, with endless opportunity to happen again, it never did. That is the strongest single piece of evidence that the wall is behind us rather than in front of us, and it is worth going slowly through. Start with what came before it, because the length of that stretch is the part people cannot hold in their heads. Life appeared on Earth early. The planet formed about 4.5 billion years ago and spent its first several hundred million years being hit hard enough to sterilize the surface repeatedly. The earliest solid traces of living things show up around 3.5 billion years ago, and there is contested chemical evidence pushing that back further still. So as soon as this world stopped being actively hostile, something alive appeared on it, not after a long wait, almost immediately, on the scale these things run on. That is one planet, and it is a small sample, and there is a selection effect hiding in it, because we could only be here to notice in a case where life did start. But taken at face value, the speed of it suggests that getting from chemistry to something that copies itself is not the hard part, which is bad news, and it is going to keep being bad news. Then, for roughly the next 2 billion years, nothing much happened. Everything alive was a simple cell, no nucleus, no separate compartments inside, no complicated machinery, bacteria and their relatives, and nothing else, for about half the history of this planet. 2 billion years is difficult to hold, so anchor it against something you already know. The dinosaurs are most people's idea of the deep past. They were around for about 165 million years, and they died out 66 million years ago. Put those together, and everything you think of as ancient fits inside about 250 million years. The stretch where nothing on this world was more complicated than a bacterium was 8 times longer than that. 8 times. If you compress the whole history of life into a single day, simple cells would have the morning, the afternoon, and most of the evening, then the merger. One organism swallowed a bacterium and, instead of digesting it, kept it. The bacterium survived inside its host. Over an enormous stretch of time, it stopped being a separate creature and became a component, a dedicated power supply sitting inside the cell that had eaten it. That component is called the mitochondrion, and there are hundreds to thousands of them in most of your cells right now. You are running on it. The energy you are using to lie there and listen to this is being produced inside something that was once a free-living bacterium, and every one of your ancestors going back 2 billion years inherited it from that single meeting. What that merger unlocked was energy. A cell with a dedicated power supply can afford to be much larger and to carry far more instructions than one without. Everything that followed, every organism you have ever seen with your eyes, required that. And here is the fact that makes it the leading candidate for the wall. It never happened twice, not once per ocean, not once every few 100 million years, once in the entire history of a planet covered in life, with 4 billion years of opportunity and every possible combination of organisms bumping into each other constantly. Compare that with the step most people assume is the hard one, which is cells cooperating into bodies. Multicellularity has evolved independently at least 25 separate times, in unrelated lineages that were not descended from each other. Plants did it, animals did it, fungi did it, several kinds of algae did it more than once. So bodies are easy. Nature reinvents them whenever it feels like it. The complex cell is a one-time event in 4 billion years, and that asymmetry is the single clearest thing anybody has pointing to a wall behind us. There is something that happened during those 2 billion years that belongs in tonight's video, because it is the one time life on this world came close to ending itself. Around 2.5 billion years ago, some of those simple cells worked out how to use sunlight. Photosynthesis. It is the single most consequential thing anything alive has ever invented here, and it had a waste product, oxygen. To almost everything living at the time, oxygen was poison. The world had been running on chemistry that did not involve it, and the organisms doing that chemistry were killed by it. As the new cells spread, they filled the oceans and then the air with a gas that was lethal to most of their neighbors. What followed is generally counted as the first mass extinction on this planet, and by some measures the largest. Not an impact, not a volcano. Life produced a waste product, and the waste product killed nearly everything. Then it got worse, because oxygen does not only poison things, it also reacts with methane, and methane at the time was doing a great deal of work holding heat in. Strip the methane out of the air, and the temperature falls. It fell far enough that ice reached the equator and stayed there, in what may have been the longest frozen period in the history of this world, lasting something like 300 million years. So within a few 100 million years of inventing the thing that would eventually make complex life possible, life on this planet poisoned most of itself and then froze the surface solid. It survived, obviously, or you would not be listening to this. But it is worth holding next to Mars and Venus, because it means this world has already come close to joining them, and the thing that nearly did it was not the sun or an asteroid. It was the organisms that lived here. There is more to the story, and it makes the picture worse rather than better. The stretch between the complex cell appearing and anything interesting happening with it is itself enormous. Roughly 1 billion years, where the world had complex cells available and did almost nothing with them. Some researchers call it the boring billion, which is not a technical term but is a fair description. So the sequence looks like this. Life starts almost immediately. Then 2 billion years of nothing but simple cells. Then one merger that never repeats. Then another billion years of very little. Then, in the last stretch, everything happens at once. If you were handed that history and asked which step is the improbable one, you would point at the merger without hesitating. Now the honest version, because this is where people overstate. We have one planet. One. Every claim about what is easy and what is hard in the history of life is extrapolated from a single example, and that example is us, which means we could only ever have been looking at a case where all the steps happen to work out. It is entirely possible the merger is common, and this planet just took its time. It is possible there are routes to complexity that do not require it at all, and simply did not happen here. Nobody can rule that out from one case. What can be said is narrower and still worth something. On the only world anybody has ever been able to examine, one step in the chain looks radically less repeatable than all the others, and it is not the one most people would guess. There is a second argument pointing the same direction, and it comes from a clock rather than from biology. It concerns how late we turned up. If the steps between a dead rock and something that can build a rover were reasonably likely, you would expect a world to produce something like us early in its habitable stretch, with billions of years left over, plenty of time to spare, arriving comfortably before closing. That is not what happened here. We turned up right near the end, and the amount of time this world has left is far shorter than almost anybody assumes. This world has about 1 billion years of habitability left, not the 5 billion almost everybody assumes, and when it ends, it will end fast. That figure comes from a study published in 2021 by 2 researchers, Kazumi Ozaki and Christopher Reinhard, who ran the same simulation more than 400,000 times, varying the conditions each time to see how the answer moved. The answer barely moved. The oxygen-rich air you are breathing has roughly 1 billion years left on it, and the ending is not gradual. Once it starts, the collapse takes about 10,000 years, which on a planet's clock is a light switch. Here is why, and it needs no equipment to follow. The sun is getting brighter, not quickly. Stars like this one brighten as they age, by roughly 1% every 100 million years, and that has been happening the entire time life has existed here. This world has been quietly compensating. As the sun brightens, more heat means more rain, and rain slowly pulls carbon dioxide out of the air and locks it into rock. Less carbon dioxide traps less heat. The planet has been cooling itself by removing its own blanket, in step with the sun, for hundreds of millions of years. That is a remarkable arrangement, and it has a flaw. Plants need carbon dioxide. It is what they are built out of. Below a certain level in the air, they cannot get enough to keep going, and the thermostat has been pushing that level down for a very long time. When it drops below what plants can work with, they die. Not some of them, the base of nearly everything, and plants are where the oxygen comes from. Every molecule of it in the air you are breathing was put there by something photosynthesizing. It is not a permanent feature of this world. It is a waste product that has been continuously topped up for 2 billion years. Stop producing it, and it starts disappearing, because oxygen is chemically eager and reacts with almost everything. Rock absorbs it, metal absorbs it. Left alone, it goes away. 10,000 years, and the air is gone. What is left afterward is a planet with high methane, almost no oxygen, and no ozone layer, which means nothing standing between the surface and the sun's ultraviolet output. It would look, chemically, like this world did before anything complicated lived on it. Everything that needs oxygen dies. That is essentially all animal life, all fungal life, and the great majority of everything else. What survives is the simple stuff, the kind that was here for the first 2 billion years and never needed air in the first place. The world does not become lifeless, it becomes microbial again, and then it stays that way until the oceans boil off entirely, which is a separate and much later problem. So the full habitable window for anything complicated on this planet is something like 5.5 billion years, and we are about 4.5 billion into it. Roughly 80% used, a fifth left. It is worth walking the order of what goes, because it does not happen all at once, and the first thing to fail is not what most people expect. Somewhere around 600 million years from now, the carbon dioxide in the air drops below what most plants can use. Most of the green things on this world stop working at that point. A smaller group that handles low carbon dioxide better carries on for a while longer, perhaps another few 100 million years. Around 1 billion years, the oxygen goes, in the 10,000-year collapse. Somewhere between 1 and 2 billion years, the oceans begin evaporating in earnest, and this world starts down the road Venus already went down. And the sun does not become a red giant and swallow the inner planets for about 5 billion years. That is the number everybody has heard, and it is the least relevant one on the list. Everything that could care will have been gone for 4 billion years by then. So the popular version, that we have 5 billion years, is off by a factor of 5, and the error is in the direction that matters. There is also the matter of what this world has already survived, which is a reminder that the clock is not the only threat. There have been 5 mass extinctions here that anybody can point to in the rock. The largest was about 252 million years ago, and it removed something like 96% of species in the ocean and around 70% of land vertebrates. The leading explanation is an enormous and sustained volcanic episode in what is now Siberia, which poisoned the air and the water over a period far longer than any human civilization has existed. Life recovered. It took millions of years, and what came back was not what had been there. So a world does not need to lose its magnetic field or boil to lose almost everything on it. It can do that from the inside, several times, and this one has. Now the argument that number supports, which is the reason it is in tonight's video rather than in a different one. If the chain of steps between a dead rock and a species that can ask this question were easy, you would expect it to complete early in a planet's window. Easy things finish with time to spare. We finished with a fifth of the clock remaining, after using 4.5 billion years to do it. That is exactly what a chain of very improbable steps looks like from the inside. When something has to get lucky repeatedly, it tends to either finish just barely in time or not finish at all, and most planets are in the not at all column. An astrophysicist named Brandon Carter made a version of this argument back in 1983, and it has held up. Our lateness is evidence that the hard part is behind us. There is a version of that which is genuinely unsettling if you sit with it, and it is not about the far future. If it takes 4.5 billion years to get here, and a world only has 5.5, then the margin for anything going wrong is thin. A slightly smaller planet cools its core early and loses its air, the way Mars did. A slightly closer orbit runs away hot, the way Venus did. A large impact at an unlucky moment resets the whole process, and there may not be time to run it again. None of those is exotic. 2 of the 3 happen next door. So the picture from this planet alone, before anybody points anything at the sky, is already strange. Life started here almost immediately, which suggests starting is easy. Then it sat at the simple cell stage for half the planet's history, and the step out of it happened exactly once. Then it took nearly the entire remaining window to produce anything that could ask about it. And the window itself is a fifth from closing. Put those together and you get a picture where the beginning is common, the middle is a bottleneck, and the timing is desperately tight, which is a reasonably hopeful picture, because it puts the wall a very long way behind us. It is also entirely built from one example, on one world, and there is a much more direct way to check it. You point something at the sky and listen for anybody else. That has been going on for 65 years now, and what has come back is the reason this video exists. Before 4 in the morning on April 8th of 1960, a man named Frank Drake drove out to a valley in West Virginia to listen to 2 stars, and he had told almost nobody he was doing it. He was 29. The head of the place had approved it on one condition, which was that it stay quiet, because being the institution that went looking for aliens and found nothing was considered a genuine risk to its reputation. He listened to a star called Tau Ceti, and then to one called Epsilon Eridani, for about 150 hours, spread across 4 months. In the first few days, something came through, strong and regular, and the room reacted the way you would expect. It was a passing aircraft. After that, for the rest of the 4 months, there was nothing at all. 65 years later, the same search is still running, and the scale of it has changed beyond recognition. Drake listened to 2 stars. The largest current effort has a target list of over 1 million of the nearest ones, plus the whole plane of our galaxy where most of the stars are, plus the 100 nearest galaxies past it. The result is the same as Drake's result. Nothing is ever answered. It is worth knowing how nearly none of this happened, because the search has spent most of its life with no public money at all. In October of 1992, NASA formally launched a serious program, properly funded, aimed at both nearby stars and the whole sky. A senator from Nevada led the effort to cut it, and the argument made on the floor was essentially that the government had no business looking for little green men. The sum was around $12 million, which against the federal budget is a rounding error, and the program was gone. Everything since has been paid for privately. An array of dishes in Northern California exists because a technology billionaire funded it. The current large effort exists because a different one committed $100 million. So the entire modern search for anybody else runs on philanthropy and has done for over 30 years, because in 1993 it was decided this was too undignified for public funds. There is a finding from last year that changes the size of the silence, and I think it is the most quietly unsettling result in this whole subject. When a dish points at a target star, it does not see only that star. It sees a cone, and at these distances a great many other stars fall inside that cone, sitting far behind the target. Those stars are being listened to as well, accidentally, and nobody had ever counted them properly, because it is difficult to know what is behind a given point in the sky at the necessary depth. Somebody worked it out in July of last year, using much deeper information about what is actually out there. The real count was about 21 times higher than the people who ran the search had believed. 21 times. Not a refinement. More than an order of magnitude more stars listened to than anybody had credited, and nobody knew. Every one of those is another place that produced nothing. There was a smaller moment in late 2025 that shows what the equipment can do now. An object called 3I Atlas passed through the inner solar system. It was only the third thing ever confirmed to have come from outside our solar system. A rock that fell in from between the stars, crossed through and left again, never to return. An object like that has spent an unknown number of millions of years drifting between stars. If anybody anywhere had ever built something and sent it out, this is the category of thing it would arrive as. So they listened to it, and the sensitivity they reached is the number to hold. They could have heard a transmitter on that rock putting out about 1/10 of a watt. 1/10 of a watt is less than the phone near you uses to hold a connection. Less than a television remote. Nobody expected an answer. The point is what it shows about where the equipment stands. When something genuinely unusual arrives now, the response takes days, and the sensitivity is absurd, and it said nothing because it was a rock. Now the honest counterweight, because everything above is one side of a ledger and the other side is large. In 2018, 3 researchers tried to answer a question the field had mostly avoided. What fraction of the possible search has actually been done? The difficulty is that it is not simply a list of stars. It includes when you happen to be listening, which is brutal, because a signal could have arrived here in 1993 from a star we have checked many times since, and there would be no trace of it, because in 1993, nobody was pointed there. Their answer, expressed as a ratio, is that the fraction covered so far is roughly a large hot tub of water compared to every ocean on Earth. An earlier version of the same comparison, before the modern effort, put it at a drinking glass. So it has gone from a drinking glass to a hot tub. That is a real improvement. It represents thousands of hours of work by hundreds of people, and it is still a hot tub. You should hold both of those facts at once, and most coverage of this subject holds only one. Before going further, it is worth knowing what we have sent, because it is almost nothing and the story is quietly ridiculous. In November of 1974, the observatory in Puerto Rico had just finished a major upgrade, and somebody decided to mark the occasion by transmitting rather than listening. Drake wrote the message himself, with help from Carl Sagan. It was a string of ones and zeros arranged so that anybody who worked out it should be laid in a grid of a particular shape would see a picture. The picture had the numbers 1 to 10. The elements our genetic material is built from. A stick figure of a person. How many of us there were. A diagram of this solar system with the third world raised up, and a sketch of the dish doing the sending. It was aimed at a dense cluster of a few 100,000 stars. On the reasoning that pointing at a crowd beats pointing at one star, the broadcast lasted about 3 minutes. The cluster is roughly 25,000 light years away, so the message arrives in about 25,000 years, by which time both the cluster and this solar system will have moved, and it will very likely miss entirely. Everybody involved knew all of that at the time. It was never meant as a serious attempt at contact. It was a demonstration that the equipment could do it, and a ceremony for a renovated dish. So the sum total of this species' deliberate transmission in 65 years is 3 minutes of radio aimed at a target it will probably miss. We have spent decades listening for something we have made essentially no effort to send. That is not a criticism, because listening is the sensible thing to do and there are real arguments against announcing yourself. But it is worth knowing, when weighing how strange the silence is, that we are part of it. There is a version of the silence that does not depend on anybody transmitting at all, and once you have it, the emptiness becomes much harder to explain away. In the 1940s and 50s, a mathematician named John von Neumann worked out the theory of machines that build copies of themselves, not as fiction, as formal mathematics. Apply that to a spacecraft and the arithmetic gets strange fast. Send one probe to a nearby star. When it arrives, it does not report back. It finds an asteroid, mines it, and builds 2 copies of itself. Those 2 leave for 2 more stars. Each arrives, mines, and builds 2 more. You know how doubling behaves. It does not take many rounds before the numbers are absurd. Even at 1% of the speed of light, which needs no new physics, The whole galaxy is covered in somewhere between a few million and a few tens of millions of years, against the age of the galaxy that is less than 1,000th of the total. Now notice what it costs whoever starts it. One probe, once. After that, the process pays for itself, because every copy is built out of material at the destination. The civilization that started it does not have to fund an empire or maintain anything. They have to succeed a single time, and then it runs whether or not they are still alive to care. That is what makes this so hard to escape. The argument does not require anybody to be long-lived, or friendly, or interested in us, or still in existence. It requires that in 13 billion years, across 100 billion stars, exactly one of them ever built one self-replicating machine and let it go. If that happened even once, the machines would be here. Not visiting, here, in this solar system, quietly doing what they do. People have looked for exactly that, nothing. And you cannot dismiss that one by saying they are too far away or too quiet, because the argument never depended on distance or on anybody sending anything. It only depended on somebody, at some point, having done a thing we ourselves are perhaps a century away from being able to do. So the sky is not just quiet, it appears untouched, in a galaxy that has had more than enough time to be crossed many times over. Against all of that, there have been 4 moments in 65 years when competent people briefly thought they had something. A few days after the 15th of August of 1977, a man named Jerry Amon was sitting at his kitchen table going through a stack of printouts from an observatory in Ohio, and he found something that has never been explained. Something had come out of the sky for 72 seconds. It was 30 times stronger than the background. It was squeezed into a single narrow note, which is a thing nature does not do, and it sat almost exactly on the one frequency people had been arguing for decades that a stranger would most likely pick. Amon circled it in red pen and wrote one word in the margin. Wow. That is where the name comes from. It was not a considered title. It was a man at a kitchen table writing the first thing he thought. They looked at that patch of sky again, dozens of times, over years. Other people have looked since, with better equipment, repeatedly, across 5 decades. It has never come back. That is the whole problem with it, and you should sit with how unsatisfying it is. Something that happens once and never repeats cannot be confirmed, and it cannot be ruled out either. It sits in the record permanently as the best unexplained thing anybody has ever caught, and it will probably still be sitting there long after you and I have finished with the question. Explanations have been offered. One involved a passing comet, which most people rejected. A more recent one from 2024 suggests a cloud of cold hydrogen, briefly lit up by a burst of radiation from a nearby star, and that idea is taken more seriously, and it is still an idea rather than a resolution. Amon himself spent decades being careful about it in public, saying over and over that something which happens once proves nothing. 10 years before that, a graduate student in Cambridge named Jocelyn Bell was going through a different stack of paper from a telescope she had helped build by hand, stringing wire across several acres of field. She noticed what she called a bit of scruff, a small mark that kept turning up in the same part of the sky. It was pulsing, with a beat of about 1 1/3 seconds, and the regularity was the problem. Nothing known in 1967 made a natural signal that precise. A clock that accurate, arriving from space, had an obvious possible explanation, and everybody in the room knew what it was. They labelled the source LGM1, Little Green Men 1. It was half a joke and half a real possibility, and for a few weeks nobody knew which. Then Bell found a second one, in a completely different part of the sky, beating at a different rate. 2 separate civilizations broadcasting clocks at the same moment was absurd. It had to be nature. What she had found was the first pulsar, the collapsed core of a dead star, city-sized, spinning several times a second, sweeping a beam past us like a lighthouse. An entire category of object nobody had confirmed existed. It won a Nobel Prize in 1974. The prize went to her supervisor and to a senior colleague. Bell was not included, and people have argued about that ever since. She has generally answered the question with more grace than the situation deserves. The third one is recent, and it is instructive in a different way. In 2019, a dish in Australia was pointed at Proxima Centauri, which is the nearest star to the Sun and has a roughly Earth-sized planet in the range where liquid water is possible. By proximity alone, it is the single most interesting target in the sky. Something narrow turned up, coming from that direction, drifting slightly in a way you would expect from a transmitter sitting on a spinning planet. It leaked to the press in December of 2020, and there was a brief global flurry. Then a team spent a year taking it apart, led by a researcher named Sophia Sheikh, and what they found is a small masterpiece of doing the boring work properly. Going back through everything, they found a whole family of related signals, turning up at moments when the dish was pointed somewhere else entirely. That is the signature of interference from close by. Some piece of ordinary electronics within a few hundred miles, probably a faulty component, throwing out a comb of frequencies. One of them happened to land in a promising slot while the dish was aimed at the right star. The published conclusion was unambiguous. It was us. The fourth is from last year, and it barely made the news. Working through material from the center of our own galaxy, near the enormous black hole at the middle of it, somebody turned up a candidate. It resolved into a previously uncatalogued pulsar, spinning hundreds of times a second, which is a genuinely useful find and is not anybody sending anything. 4 candidates, 65 years, everyone resolved, or in the case of the first, resolved as far as anybody can manage without it happening again. It is worth stopping on what any one of them would have meant if it had held. Not a message, nobody expects a message, just a narrow note from a particular direction that keeps coming back when you look again. That alone would settle the oldest question anybody has ever asked. It would mean the wall is not in front of us because somebody else got past whatever it is and is still there. It would mean we are not the only ones left. It would mean that every dead world in this solar system is a local accident rather than the normal outcome. One repeating note, and the whole of tonight would be a different video. 4 times. Somebody has sat with that possibility for a few days or a few weeks. Jerry Amon had it at a kitchen table. Jocelyn Bell had it in a room in Cambridge. And every time, it has gone the same way. Now the thing worth taking from that, because it is not the obvious thing. The failures were productive, and that is not a consolation prize. It is the actual record. Bell's little green men turned out to be a new kind of object in the universe. The Proxima candidate produced a verification method that is now standard. The Galactic Center candidate added a pulsar to the catalogue. Every serious false alarm in this field has ended with somebody learning something real, either about how the universe works or about how our own machines fail. There is a reason for that. The search is looking for the strange, and anything that stands out from the background is either artificial or it is something natural nobody had catalogued yet. Both are worth finding, and the second is far more common. So the pulsars in every astronomy book you have ever opened are in that book partly because somebody spent a few weeks in 1967 wondering whether they were a message. There is one practical thing to carry out of all this, because you will see another headline about this eventually, and it is worth knowing how to read it. A real detection has to happen more than once. Something that occurs a single time cannot be confirmed, which is precisely why the wow signal is stuck where it is. It has to disappear when the dish points away. If it is still there when you aim at empty sky, it is coming from here, and somebody else, on another continent, with different equipment, has to see it too. The Proxima candidate passed some of those and failed the one that mattered. The wow signal cannot be tested against any of them because it only ever happened once. So the record, stated plainly, is that in 65 years of listening, there have been 4 moments where competent people briefly wondered, and there are 0 confirmed detections, not weak ones, not disputed ones, 0. There is one more thing about the wow signal worth knowing, and it is about what happens to a thing like that over 50 years. It has become the most examined 72 seconds in the history of the subject. People have gone back to the original paper repeatedly, decades later, with better ideas about what else could produce it. Somebody found a plausible natural explanation in 2024 using material nobody had thought to check. And it will never be settled, because the only test that would settle it is hearing it again, and it has had 5 decades to come back, and it has not. Eamon lived with that for the rest of his life. He found the most suggestive thing anybody has ever caught, at a kitchen table, going through paperwork days after the fact, and then spent 40 years telling people carefully that it did not prove anything. That is closer to what this work is actually like than any film has ever managed. There is one exception to the zero, and it is not a signal, it is a smell. For a few days in April of 2025, a large part of the world believed we had found life on a planet 124 light-years away, and the reason was a smell. There is a molecule called dimethyl sulfide. On this planet it is made almost entirely by living things. Plankton in the ocean produce it. It drifts up into the air, and if you have ever stood near the sea and noticed a particular smell that is not quite salt, a good part of what you were smelling is that molecule. For a long time nobody knew any way to make much of it without something alive being involved. So when a team announced they had found signs of it in the air of a distant planet, the coverage was enormous. This was described everywhere as the strongest hint of life beyond Earth anybody had ever obtained. The planet is called K218b. It is about 2.5 times the width of this one and 8.5 times the mass, which puts it in a category we have no example of at home. Bigger than Earth and smaller than Neptune, it orbits a small cool star every 33 days, close in, but the star is dim enough that close in is not necessarily too hot. An astronomer at Cambridge named Niku Madhusudan had proposed that worlds like it might be something nobody had considered, a deep ocean of water underneath a thick blanket of hydrogen. If such a thing exists, it could be habitable in a way that looks nothing like here. That is the picture the headlines were carrying, an ocean world 124 light-years off, with the smell of plankton in the air. There is an earlier chapter to this world's story that is worth having, because it establishes the pattern before the pattern repeats. In 2019, 2 separate teams announced they had found water in the air of this same planet. It went round the world as the first detection of water on a possibly habitable world beyond our own. Later work complicated that considerably. The equipment being used could not cleanly separate the fingerprint of water from the fingerprint of methane in that part of the rainbow. The feature was real. What was producing it was not settled, and a good deal of the work since has favoured methane. So the first headline about this planet was also a claim that softened under examination. Nobody did anything wrong. The equipment was being pushed to the edge of what it could do, and at the edge, things are ambiguous. Here is what has happened since, and I think this is the most valuable part of the story even though almost nobody followed it. Other teams got hold of the same material, which is normal, and several of them reached different conclusions. A combined look published in 2025, which tested everything together rather than one piece at a time, concluded that the evidence was insufficient. Not that the molecule is absent, that what had been collected could not support the claim. Another paper put it more bluntly in its title, stating that the planet does not meet the standards of evidence for life. The disagreements came down to unglamorous things, small assumptions about how the equipment behaves, which of several plausible descriptions of the atmosphere you fit. Change those within reasonable bounds, and the signal grows, shrinks or disappears. Then the original team went back and did something more thorough, and it is a good example of scientists arguing with themselves properly. Instead of looking for the molecule they expected, they checked their material against 661 different possibilities and asked which fitted best. Dimethyl sulfide was still the one that came out on top. That sounds like vindication, and it mostly is not. For a reason, the authors flagged themselves. The bar they used to screen candidates sat slightly below the conventional one, and the results still leaned on those same assumptions about the equipment that the critics had already identified as the soft spot. Their conclusion was that the molecule remains a plausible candidate and that more looking is needed, not a detection, a candidate. There is a deeper problem underneath all of it, and it is about the planet rather than the molecule. The whole interpretation depends on there being an ocean down there. The smell only means anything if there is somewhere for plankton to live. Several groups have argued the planet is more likely something else entirely. A gas-rich world with no surface ocean at all, where beneath that thick hydrogen blanket, the pressure and heat are high enough that any water is something stranger than a sea, or a layer of molten rock. Descriptions of that kind can reproduce everything seen without any ocean, and without anything alive. Which of those the planet actually is, has not been settled. That is not a detail. If there is no ocean, the whole reading has nowhere to stand. Meanwhile, the other leg has been weakening independently. The strength of that molecule as a sign of life was always that nothing except life makes much of it. That claim has been eroding. Laboratory work has produced it with no biology involved at all, and it has turned up in the material around a comet in our own solar system, where there is certainly nothing alive. So the molecule is looking less exclusive than it did, at the same time as the finding is looking less secure. Where that leaves the planet is genuinely unresolved, and I would rather give you that than a clean ending. There may be dimethyl sulfide there. If there is, it may or may not need life to explain it. Better looks are being taken, and the question is open. What I want you to take from it is not the verdict, it is the shape of what happened. This is what the closest approach looks like. Not a signal, not a message, not a photograph. A slight change in the color of starlight, argued over for 3 years by careful people using the same material and reaching different answers, turning on assumptions about how a piece of equipment behaves. If we ever do find life somewhere else, the odds are overwhelming that it arrives looking exactly like this. Ambiguous, contested, resolved slowly, and probably never with the certainty anybody wants. The films have a moment. Reality has a threshold, and an argument about equipment. There is something in that worth carrying with you, and it is not about this planet in particular. You almost certainly saw the headline in April of 2025. You almost certainly did not see any of what came after it, because the unraveling of a claim never gets the coverage the claim did. That asymmetry is not anybody's fault, it is just how attention works. Which means your picture of where this subject stands is probably built out of announcements rather than out of resolutions, and the resolutions have mostly gone one way. If you want a rule for reading the next one of these, and there will be a next one, it is this: wait a year. Not because the people making the claim are careless, but because the interesting cases sit right at the edge of what the equipment can do, and the edge is where things are ambiguous. A year is roughly how long it takes for other people to get hold of the same material and see whether it holds. Almost nothing in this field has ever survived that year. That is not a criticism of the field. It is what a working field looks like from the outside. And there is one more thing to notice, which loops back to everything before it. If that world does turn out to have an ocean with something alive in it, then by the argument from earlier, that is not good news. Life at 124 light-years, started independently, would mean the early steps are easy, and the wall is somewhere in front of us. The world would celebrate for a week. The people who take that argument seriously would go very quiet. That is one planet though, and it is one of thousands now known. The number of places is the part of this story that has changed most in a single lifetime, and it is the reason the silence became a problem rather than a curiosity. When Frank Drake pointed a dish at Tau Ceti in 1960, he did not know whether there was anywhere out there for anybody to be standing. That is difficult to appreciate now. The number of confirmed worlds outside this solar system on the day he started listening was 0. Not a small number, none. Whether other stars had planets at all was a real open question, argued about seriously, with no evidence on either side. It stayed that way for another 35 years. Then in October of 1995, 2 astronomers in Switzerland announced they had found one, and almost nobody believed them at first, because the thing made no sense. Michel Mayor and Didier Queloz had been watching a star called 51 Pegasi. What they detected was a wobble. The star was being tugged slightly toward us and then slightly away on a repeating cycle, which is what happens when something heavy is going around it. The cycle repeated every 4¼ days. That was the problem. Something heavy enough to move a star that much should be a giant like Jupiter, and Jupiter takes 12 years to go around the Sun because it lives far out where giants are supposed to form. This one was going around in 4 days, closer to its star than Mercury is to ours. Every explanation of how planets form said that was impossible. A good part of the field's first reaction was that the measurement must be wrong. It was not wrong. It was confirmed within weeks, and what followed was the realization that our own arrangement is not the template. Planets move, giants form far out and spiral inward. The tidy setup here, rocky worlds close and giants distant, is one outcome among many. The two of them shared a Nobel Prize for it in 2019. What happened next was faster than anybody expected. A space telescope called Kepler launched in 2009 with an almost aggressively simple design. It pointed at one patch of sky and stared. It did not move. It watched about 150,000 stars continuously for 4 years and measured how bright each one was, over and over. What it was looking for was a dip. When a planet passes in front of its star from our angle, the star gets very slightly fainter for a few hours. There is a catch built into that, and it is the reason Kepler had to watch so many stars at once. It only works if the orbit happens to be edge-on from our direction. Tilt the system slightly, and the planet passes above or below the star from where we are, and we see nothing. For a world at Earth's distance from a Sun-like star, the odds of that alignment are roughly 1 in 200. So Kepler was always going to miss the overwhelming majority. That was accepted from the start, because the goal was never a complete catalogue, it was a rate. If you find a certain number, and you know you could only ever have seen about 1 in 200 of them, you can work backwards to how many are actually there. Kepler confirmed roughly 2,700 worlds. Thousands more have come from other efforts since, including one that sweeps the whole sky rather than a single patch. But the count is not the important number, the rate is. When you correct for all of it, the answer lands somewhere that would have sounded like wild speculation in 1990. Something like 1 in 5 stars similar to the Sun has a roughly Earth-sized world orbiting at a distance where liquid water could sit on the surface. I want honest error bars on that, because it gets quoted with far too much confidence. Different groups using different assumptions have landed anywhere from about 1 in 10 to about 1 in 3. Call it roughly a fifth and hold it loosely. Even at the pessimistic end, the arithmetic that follows is overwhelming. Our galaxy holds somewhere between 100 billion and 400 billion stars. Take the low end. Take only the ones broadly like the Sun, which is a minority. Take the worst planet rate. You still land on billions of Earth-sized worlds in the liquid water range in this galaxy alone. And this galaxy is one of hundreds of billions we can see. Those are the numbers underneath everything else tonight. When Drake started, the silence meant nothing, because there might genuinely have been nowhere for anybody to live. Now there are billions of candidate addresses in our own galaxy, and the number of answers is still 0. That changes the entire reason this problem got harder rather than easier. Every discovery of the last 30 years has made the emptiness stranger. Now the honest correction, because the phrase habitable zone does a great deal of misleading work. It means the distance at which liquid water could exist on the surface of a rocky world, given a suitable atmosphere. Given a suitable atmosphere. That clause carries most of the weight, and it is almost never said out loud. It is a statement about how much light a world receives. It is not a statement about the world. It says nothing about whether there is any air at all, or what it is made of, or whether the surface is molten or frozen. Venus sits in the Sun's habitable zone by several common definitions. Its surface is hot enough to melt lead. There is a system that has become the test case for all of this, and what has happened to it over the last few years is sobering. About 40 light-years away, there is a small cool star, with 7 worlds around it, all roughly Earth-sized, 3 or 4 of them in the range where liquid water is possible. It was announced across 2016 and 2017, and it was immediately the most exciting thing anybody had found, because 7 rocky worlds around one nearby star is an entire laboratory in a single place. They are packed in tight. All 7 orbit closer to their star than Mercury does to the Sun, because the star is so dim. A year on the innermost one lasts about a day and a half. When the James Webb Space Telescope became available, they were near the front of the queue, and the first 2 examined were the innermost pair. What was checked was heat, and the logic behind it is something you already know from your own weather. Air moves heat around. A world with a thick atmosphere has winds carrying warmth from the lit side to the dark side, so the difference between the two is modest. That is why the night where you are is cooler than the day, and not hundreds of degrees colder. Strip the air away, and that stops. The lit side bakes, the night side freezes, and the gap becomes extreme. Both worlds came back looking bare. The innermost showed a daytime temperature consistent with no meaningful atmosphere at all. The second showed no sign of a thick blanket either. 2 for 2. No air. I want to be careful how far that generalizes. Those are the 2 closest to their star, the 2 most exposed, and the ones you would expect to be stripped first. The ones further out, the ones actually in the water range, have not been ruled on, but it is not encouraging, and it points straight at the problem with these small cool stars. They spend their first billion years throwing out flares far more violent than anything our Sun produces, and a world that close has to survive that, with its air still attached before anything else can matter. Most of the stars in the galaxy are that kind. If those worlds are routinely stripped bare, then a large fraction of the billions of candidates come off the board immediately. So the honest version is this: there are billions of worlds the right size and the right distance from their star. How many of them have air, oceans, stable weather, and the 4.5 billion uninterrupted years it apparently takes to produce anything that can ask about it? Nobody knows. It could be a large fraction. It could be almost none. What is certain is that the number of addresses is enormous, and the number of confirmed inhabited ones is 1. Somebody tried to turn all of that into a single line of arithmetic on a blackboard in a room in West Virginia. About a year after Project Ozma found nothing. In November of 1961, 11 people met for 3 days to work out whether there was any sensible way to think about this at all. Drake organized it. The mix was unusual. Radio astronomers, chemists, a young researcher in his mid-20s named Carl Sagan, years before anybody outside the field had heard of him, and a neuroscientist who studied dolphins, invited on the reasoning that talking to a non-human intelligence was the nearest available practice run. During the meeting, one of the chemists received word that he had won the Nobel Prize. He had it announced to the room, and the meeting carried on. They jokingly named themselves the Order of the Dolphin, and a few of them wore small pins afterward. Drake had a problem before it started, which was how to structure 3 days of conversation about something nobody had any evidence for. So the night before, he worked out what would actually determine the number of civilizations we could hear, broke it into separate pieces, and wrote the chain on the blackboard. That is where the Drake equation comes from. It was never a theory. It was an agenda. Each piece was a topic, and each topic had somebody in the room qualified to argue about it. If you have ever been handed a meeting with no agenda and no information, you know roughly the situation he was in, except that his subject was whether anybody else exists. The chain in plain words goes like this: how many stars form? How many of those have worlds? How many of those worlds could hold life? How many of those actually get life? How many of those get intelligence? How many of those build something we could hear? And finally, how long any of them stays audible? 7 numbers, multiplied together. In 1961, every one of them was a guess, not an estimate with uncertainty attached, a guess. 3 of them are no longer guesses. How many stars form is counted. How many have worlds turned out to be nearly all of them, where serious people in that room had argued it might be 1 in 1,000. And how many suitable worlds per system has become the rough figure from earlier tonight? Every single one of those 3 came back larger than the pessimists expected. That is the actual scientific story of the last half-century on this question. The 3 pieces we learned how to check all pushed the answer up, and the sky got no louder. The remaining 4 have not moved at all, and among them 1 dominates everything. How long does anybody stay audible? Every other piece is about how often civilizations appear. That one is about how long they stay, and because it multiplies through everything, it swamps the rest. Work it through and you can see why. If a civilization stays audible for 100 million years, the galaxy should be crowded because they accumulate. New ones appear while old ones are still going. If a civilization stays audible for 100 years, almost none of them overlap. They flicker on and off across billions of years, scattered through 100,000 light years of space, and the odds of 2 existing close enough and at the same moment are close to nothing. Same galaxy, same rate of appearance, 2 completely different skies, and the only thing that changed is how long anybody sticks around. Our own audible lifetime, so far, is about 100 years. That is the entire window in which this world has been visible as anything other than a planet with unusual air. So we sit on the lowest possible value of the one number that matters most, and nobody knows whether it goes up from here. You are living inside that number right now, which is a strange thing to be told, and it is literally true. Everything this world has ever broadcast has gone out during this single human lifetime. If somebody 60 light years away pointed something at this star tonight, the earliest thing they could possibly catch left here around the time your grandparents were young. Beyond that distance, from anybody's point of view, this world is still a planet with unusual air and nothing on it. That is the whole of our contribution to the noise of the galaxy. 1 century, expanding outward at the speed of light, into a galaxy 100,000 light years across. If somebody out there ran the same search we are running, and pointed at this star at any moment in the last 4 billion years except the last 100, they would have written us down as silent too. That is where every argument in tonight's video actually lives. Stripped of the language, the claim that something reliably ends civilizations is a claim about that single number. It says the answer is short, everywhere, for reasons nobody has identified. The estimate that room produced, after 3 days of arguing, was that the number of audible civilizations in the galaxy was somewhere between 1,000 and 100 million. That range is so wide it is almost a joke, and the people who produced it knew it. Sagan later described the exercise as a way of organizing ignorance rather than dispelling it. But 3 of those 7 pieces did get answered, over decades, at enormous expense, by people building equipment and going to look. The equation did not answer the question. It told everybody exactly which questions could be answered, and the field spent 50 years answering the ones that were reachable. What it also did was make the problem sharper. In 1961, you could shrug off the silence by saying we did not know whether there was anywhere for anybody to live. That escape route is closed. Roughly 92% of the worlds that will ever be capable of holding life have not been built yet. That figure comes from a study published in 2015, and if it is even approximately right, it dissolves a large part of tonight's problem without requiring anybody to die. The reasoning behind it is simple enough to follow without any of the arithmetic. The universe is about 13.8 billion years old. Against a human life that is enormous. Against the lifespan of the universe, it is essentially nothing. Star formation is nowhere near finished. There is still an immense amount of gas available, and it will keep collapsing into stars for a very long time. And the most common kind of star is small, cool, and stingy with its fuel, and one of those can burn steadily for trillions of years. Trillions. Our sun gets about 10 billion years in total and is halfway through. A small star forming today will still be shining when the sun has been a cold cinder for 1,000 times longer than the universe has so far existed. So if you take the full habitable history of the universe and ask where in it we are sitting, the answer is that we are at the very beginning, not in the middle, not late, in the opening moments. There is a second reason we might be early, and it has to do with what worlds are made of. The first stars had nothing to work with. The early universe was hydrogen and helium and almost nothing else. Carbon, oxygen, silicon, iron, everything a rocky world or a living thing requires has to be manufactured inside stars and then scattered when those stars die. That takes generations. Each round enriches the gas a little more, and only after several rounds is there enough heavy material lying around for rocky worlds to be common. This one formed about 9 billion years in. Not first generation, but not late either. Put those together, and the silence needs no wall at all. The sky might be quiet because we are among the first, and the crowd simply has not arrived. I want to be careful how strongly I put that. It rests on projections of future star formation, and different assumptions shift the number. But even at the pessimistic end, the conclusion that we are early is hard to escape. That is the strongest of the explanations that require nobody to die. There are several more. The second we have already met, and it belongs here anyway. The search so far is a hot tub against every ocean on Earth. Even after 65 years, even after 21 times more stars than anybody had counted, finding nothing is exactly what you would expect whether or not anybody is out there. You cannot conclude much from an empty net when you have dipped it once in a very large sea. The third is about us rather than them, and it is the one that changed my own thinking most while putting this together. Radio may be a technology with a 100-year window, and we may already be closing ours. Think about what has happened to broadcasting in your own lifetime. The old way was enormous transmitters pushing signal out in every direction, most of it spilling uselessly into space, because that was the only way to reach everybody in a region. That is dying. Analog television has been switched off across most of the developed world. Content moves through cables and fiber, which leak nothing. Satellite signal is aimed in tight beams at the ground rather than sprayed outward. Mobile networks use low power because power is expensive and interference is a nuisance. Efficiency and leakage are opposites. As a civilization gets better at talking to itself, it gets quieter, because every watt thrown into empty space is a watt wasted. This world was probably at its loudest somewhere in the second half of the 20th century, and we have been getting fainter ever since. If that is a general pattern, then the window in which anybody is loudly audible is not the length of their existence. It is the brief stretch between inventing radio and getting good at it. A century, maybe two. And that gives you a short window without anybody dying at all. They are not gone, they are on fiber. The fourth is that complex life might simply be rare for ordinary reasons, with no wall and no catastrophe. The argument is that a long list of conditions had to line up here, and each one is uncommon. A large moon that has kept this world's tilt steady rather than wandering. Plate tectonics, which recycles the crust and regulates the air over geological time, and which no other rocky world in this system appears to have. A magnetic field strong enough to hold an atmosphere for billions of years, which is exactly what Mars lost. A large outer planet in a stable orbit. A position in the galaxy far from the crowded, radiation-soaked center. And on top of all that, 4.5 billion years without an interruption severe enough to reset everything. None of those individually is a wall. Multiply enough uncommon conditions together, and you get rarity without needing anything to go wrong. That argument has weakened somewhat since it was first made. Several items on the list have turned out to be less essential than they looked, but the general shape of it survives, and the two dead worlds either side of us are the evidence for it. The fifth is the simplest and the easiest to overlook. They might not be using radio. Everything so far has assumed that somebody out there would talk in ways we would recognize, on the channels we happen to think of, using methods we happen to have invented. That is 1 century of our own technology projected across a galaxy. Somebody 10,000 years older than us is not 100 years more advanced. They are 10,000. Whatever they are doing, the odds that it resembles what we started doing in the 1920s are not obviously good. The counter-argument is decent. Physics is the same everywhere, Radio genuinely is efficient for crossing these distances, and anybody energetic would likely be doing something detectable, whether or not it was meant for us. But it is not airtight, and nobody thinks it is. The sixth is that going anywhere might just be extremely hard. A great deal of this rests on the idea that anybody who lasts will spread, because that is what life does. The fastest thing we have ever launched away from the sun is moving at around 38,000 miles per hour, and at that speed, the nearest star is a 70,000-year trip. Crossing that gap needs either enormous energy or enormous patience, and there is no obvious reason to bother. Everything a civilization needs is available in its own system. There is nothing worth hauling across 4 light years. Maybe they last a long time, stay home, live off their own star, and never leave. That is not a wall. That is a preference, and it would look identical to us from here. And then there is a family of explanations proposing that they are here, or watching, or deliberately keeping quiet. I set those aside, not because they are impossible, but because they cannot be tested. Any explanation that accounts equally well for every possible observation is not doing any work. If a story predicts silence whether or not anybody is there, then hearing silence tells you nothing about it. You have not explained the mystery, you have given it a name. So there are the honest alternatives, and I will give you my own reading rather than pretending I do not have one. I find the first and the third most persuasive, and they fit together well. We may be early, in a universe where the overwhelming majority of habitable worlds have not been built yet, and the window in which anybody is loudly audible may be a century or two, however long they survive. Put those together and you get exactly the sky we see, with no wall, no catastrophe, and nobody dead. Not because the universe is empty, but because it is young, and because everybody eventually goes quiet. Notice that both of those are undramatic. There is no lesson in them, no warning, nothing for anybody to act on. I suspect that is a good part of why they get so much less attention than the version where something is waiting for us. The frightening explanation is not the more likely one. It is the more interesting one, and those are very different things. There is one consequence of the early explanation that I think deserves saying out loud, because it is the only part of tonight that comes with any weight attached. If we are among the first, then a great deal of what happens next is on us. Not in a grand way, in a plain one. If most of the habitable worlds have not been built yet, and if life is rare and slow and easily interrupted, then whatever is alive right now in this galaxy is a very small sample of everything that will ever be alive in it, and we are part of that sample. Every other world we can examine is dead. 2 of them were probably not, once. The difference between them and us came down to the size of a core and the distance to a star, and neither of those was anybody's decision. What happens to this one is, at least partly, I want to be careful here, because this is exactly the point where this kind of video usually turns into a lecture, and I have no interest in giving you one at whatever hour it currently is, so I will put it as plainly as I can and leave it alone. On the evidence available, this is the only world anybody has ever found with anything alive on it. It has 1/5 of its habitable time left. Everything that has ever happened to anyone happened here. That is not a warning, and it is not a call to action. It is just the situation, stated once. Back to the question. Frank Drake died in 2022, at 92 years old, having spent his entire adult life on a question he always knew he would probably not get to answer. He was 29 when he drove out to that valley in West Virginia. He lived to see the number of known worlds outside this solar system go from 0 to thousands. He lived to see it settle that almost every star has planets, which in his youth was an open argument. He lived to see the air of worlds around other stars examined for the smell of life, which in 1960 would have sounded like a fantasy. He also lived to see 62 more years of nothing. In interviews, he was consistently clear that not finding anything was an acceptable outcome. His argument was that the question was worth asking regardless of which way it came out, and that a confirmed absence would matter as much as a detection. That is a much harder position to hold than it sounds, across 6 decades with your name on it. Think about what that actually asks of somebody. You pick a question in your 20s, going in, that the odds of it resolving while you are alive are poor. You do the work anyway, carefully, for 60 years, and you die with it open. Most people would find that unbearable and choose something else. A few hundred have not, and you are the beneficiary of that choice, in a small way, because everything you have heard tonight exists because people were willing to spend their working lives on something that might never pay out. The count of worlds, the rate, the limits, the 4 candidates that were checked properly and eliminated instead of being announced. None of that had to happen. It happened because a small number of people decided the question was worth their time, even if the answer arrived after them. And he was right, which is what this last stretch is about. Finding nothing is not the same as learning nothing. There is a famous example of that from a completely different corner of science. In 1887, 2 men in Cleveland built the most sensitive machine of its kind that had ever existed, ran the experiment it was designed for, and measured absolutely nothing. The result was 0, over and over, for years. It is the most famous failed experiment in the history of physics, and it did not fail. The absence was the answer. 18 years later, Einstein built a good part of relativity on top of it. The value came entirely from one thing. Those 2 could state precisely what they would have seen if it had been there. Because they could state it, the 0 meant something specific. So the useful question about 65 years of silence is not what it might mean. It is what it rules out. Here is what has actually been established, as narrowly and honestly as I can put it. Take the strongest deliberate signal this planet has ever sent. For decades that was a dish in Puerto Rico that could bounce a beam off asteroids and read the echo, 1,000 feet across, which finally collapsed in 2020. If something of that class existed on a world around any of the nearest few thousand stars, and it was aimed roughly our way, and it was running on the channels we checked during the hours we happened to be listening, we would have heard it. We did not. So it is not there, under those conditions. That is a real constraint, and it is worth reading twice for how many conditions it carries. It says nothing about somebody transmitting in a tight beam aimed elsewhere, nothing about somebody who transmitted for 1,000 years and stopped before humans existed, nothing about the overwhelming majority of stars that have never been checked at all. But it is not nothing, and it used to be nothing. There is a second constraint, and it does not require anybody to be transmitting. Any civilization using enormous amounts of energy has to dump waste heat somewhere, and heat is visible. A star that appears too bright in the infrared for its ordinary brightness would be a candidate for something very large built around it. People have run that check across millions of stars. A handful of oddities came out, and follow-up work has generally explained them as distant galaxies sitting in the same line of sight. So there is an upper limit on how many stars in that sample can be substantially enclosed by anything constructed, and the limit is low. None of that answers the question. All of it narrows it, and narrowing is what science does before it answers. There is a comparison from another field I find useful here. For decades, physicists have been watching enormous tanks of water underground, waiting for a single proton to fall apart. Some theories predicted it should happen, rarely, on timescales far longer than the age of the universe but not infinitely long. Nobody has ever seen it. The count is 0 after decades. That 0 is one of the most valuable numbers in physics. Because the tanks are so large and have run so long, the absence sets a floor on how long a proton must last, and that floor is high enough to have killed the simplest versions of those theories outright. Nobody found anything, and entire families of theory were eliminated. That is the shape of what has happened here, and it is why the search is not a failure despite having found nothing in 65 years. The galaxy is not densely packed with loud, long-lived, expansionist civilizations broadcasting in every direction on the channels we thought were obvious. That was a live possibility in 1960. It is now excluded. For the volume examined, what remains possible is a long list: rare ones, quiet ones, distant ones, brief ones, ones that came and went before we existed, ones doing something we would not recognize, and none at all. I want to be honest that this is a less satisfying answer than either dramatic option. It would be cleaner to tell you the silence proves we are alone, or that the search has barely started so it means nothing. Both are available and both are wrong. The accurate position is that an unanswerable question has been converted into a bounded one, and the bounds are still very wide, which is worth pausing on because of how recent all of it is. Somebody born in 1960 has lived through the entire history of this as something you can actually investigate. When they were born, there were no confirmed worlds outside this solar system. No search had ever been conducted, and whether anybody else existed was a matter for philosophy and fiction. In one lifetime, it became something with equipment, budgets, published limits, and a standard strict enough that 4 separate candidates were examined and eliminated on the evidence rather than on opinion. That is a remarkable thing to have happened in 65 years, and it tends to get lost underneath the drama of the unanswered question. So what should you actually believe? I am not going to give you a confident answer, because there is not one available, and anybody offering one is selling something. But I can tell you what the evidence supports and what it does not. It supports the claim that the loud, obvious version of a populated galaxy is not the one we live in. That has been established for the volume searched. It does not support the claim that something reliably kills civilizations. That is an inference from absence, resting on a framework rather than on anything measured, and there are several explanations that fit the same silence without requiring anybody to die. It supports the claim that Earth-sized worlds at the right distance are extremely common, because that has been counted. And it leaves entirely open the 2 questions that would settle everything. How often life starts, and how often it gets complicated. On both of those we have exactly one example, and you are it. There is a question underneath all of this that people ask less often than they should, which is whether it would be better to know. There are 2 ways this ends, and they are worth laying side by side. In one of them, somebody detects a repeating narrow note from a nearby star, confirmed, checked from 3 continents, unambiguous. That settles it. The wall is not in front of us, because somebody else got past whatever it is. We are not the only ones left. Every dead world in this solar system becomes a local accident rather than the normal outcome, and the future is open. In the other, the search runs another 65 years, at 100 times the current scale, and finds nothing at all. That would also be informative, and considerably less comfortable. At some point the hot tub becomes a swimming pool, becomes a lake, and the absence starts to mean something it does not mean yet. Nobody knows which of those we are heading toward. What is worth noticing is that we are the first generation for whom either is even possible. Everybody before 1960 lived and died with the question completely open, not because the answer was hidden, but because there was no way to look. That changed inside a single human lifetime, and it is not going to change back. There is one more thing the silence measures, and it is not about anybody else. Every constraint described tonight was produced by people building equipment, arguing about calibration, checking each other's work, and publishing results that mostly said no. 65 years of that, on a question with no guaranteed payoff, funded for most of that time by private donors because a government decided it was undignified. The searching is a measurement too. It says something about what this species does with a question it cannot answer, which is that a few hundred people will spend their entire careers on it, anyway, knowing they will probably die before it resolves. Drake did exactly that, and said it was worth it. Let's pull every thread we followed tonight together, because they arrived in an order chosen for what matters rather than for chronology, and they fit into something cleaner than the sequence suggests. We started with the fact that every world we have ever looked at closely is dead, not empty, dead. Mars had rivers, and you can still see the channels they cut. It had a thicker atmosphere and a magnetic field, and it lost all 3 because it is small. It cooled early in the middle, and then the sun took its air away 1 molecule at a time over 1 billion years. Venus is almost exactly the size of this world, and probably had oceans for billions of years. It got slightly too much heat. The water went into the air trapped more heat, and the process ran one way until there was nothing left. The surface is hot enough to melt lead, and everything we have ever landed there has been destroyed within hours. two neighbors, both probably habitable once, one frozen and one boiled, and neither of them coming back. Then a moon with no air, a Mercury with none, four giants with no surface to stand on, and something like 300 moons, of which exactly 2 are worth checking, and neither has been checked properly. One world in this entire system has anything alive on it, and you are lying on it. We found the strangest conclusion in all of this, sitting in a metal tube on the Martian surface. If we go and collect that tube, and the markings in that rock turn out to have been made by something alive that started separately from us, that is the worst news this species has ever received. Because every early step you discover is easy pushes the wall forward, toward us, and eventually past us. The world would celebrate for a week, and the people who think carefully about it would go very quiet. We found the one thing on this planet that looks genuinely improbable, and it is not what most people would guess. Life appeared here almost immediately once the surface stopped being sterilized, which suggests starting is easy. Then everything alive stayed a simple cell for 2 billion years, 8 times longer than the entire span of the dinosaurs. Then one cell ended up inside another and survived, and every plant and animal and fungus descends from that single event, and it never happened again. Compare that with bodies, which nature has invented independently at least 25 separate times. We found the clock, and it is much shorter than anybody assumes. This world has about 1 billion years of habitability left out of roughly 5.5 billion total, and when it ends, the collapse takes about 10,000 years. We used 4.5 billion of those years getting here. Arriving that late, with 1/5 of the clock remaining, is what a chain of very improbable steps looks like from the inside. We found 65 years of listening that has produced nothing, and a search far larger than most people realize. A recount last year showed one effort had swept up about 21 times more stars than its own operators believed. An interstellar rock was checked down to a transmitter weaker than a television remote, and all of it, since 1993, paid for privately, because a government decided the question was undignified. We found that the same search is still, by any honest accounting, a hot tub of water drawn from every ocean on Earth. Both of those are true at once, and holding only one of them is how people end up with confident opinions about this. We found 4 moments in 65 years when competent people briefly wondered. A signal in Ohio that lasted 72 seconds and never came back, with one word written beside it in red pen. A pulse in Cambridge labelled Little Green Men before it turned out to be an entirely new kind of star. A candidate from the nearest star that resolved into a faulty piece of equipment somewhere on this planet. And a signal from the galactic center that turned out to be a pulsar nobody had catalogued. Every false alarm in this field has ended with somebody learning something real. We found the closest anybody has come, and it is worth remembering how it looked from where you were sitting. A world 124 light-years away, a molecule that here is made almost entirely by ocean plankton, a headline that went round the world for about a week, and then 3 years of careful people quietly taking it apart over questions about how a piece of equipment behaves. You almost certainly never saw that part reported. We found billions of addresses. Before 1995, the number of known worlds outside this solar system was 0, and the silence meant nothing because there might have been nowhere for anybody to live. That escape route closed. Roughly 1 star in 5, like the Sun, has an Earth-sized world in the range where water could be liquid. And then the sobering part. The first 2 worlds examined in the most promising nearby system came back with no air at all. And we found the explanations that require nobody to die. That about 92% of the habitable worlds that will ever exist have not been built yet. And we are sitting in the opening moments of a universe that will keep making them for trillions of years. That radio may be 100-year technology, and we may already be going quiet, as fiber replaces broadcast and every watt spilled into space becomes a watt wasted. Those two together produce exactly the sky we see, with no wall and no catastrophe. Here is the honest bottom line. We do not know. That is not a failure of tonight, it is the state of the subject, and I would rather hand you that than a false resolution. What we do know is narrower and more useful than it sounds. The galaxy is not densely packed with loud, long-lived civilizations broadcasting in every direction. That was a live possibility once, and it has been measured out of existence for the volume examined. We know that places to live are abundant because they have been counted. We do not know how often life starts or how often it gets complicated. On both of those we have one example. You are the example. Every estimate anybody makes about how common life is in the universe is extrapolated from the world you are lying on. And we know that the frightening explanation is not the more likely one, it is only the more interesting one, and those are very different properties that get confused constantly. If you carry one thing out of tonight, make it that last distinction. A wall in front of us is dramatic, it comes with a warning attached, and it makes a better story. Being early in a young universe and going quiet as our technology improves explains the same sky with nothing at stake and no lesson for anybody. The evidence available today does not favor the first one, so come back to where this started. Every world we have looked at closely is dead. Something reliably ends things. Whatever it is has already happened to everybody else, and we might be the only ones left. That might be true. It follows from a small number of things nobody disputes, and serious people hold it. It might also be that we are early, that the universe is 13 billion years into a habitable history running for trillions, that most of the worlds have not been built yet, and that the reason nobody has spoken is the same reason a room is quiet an hour before anybody arrives. Both explain the silence perfectly, and tonight there is no way to choose between them. What is certain is smaller and stranger than either. On one ordinary world, around one ordinary star, in a solar system where every other world is dead, something started listening 65 years ago and has never stopped and has never once been answered. Thank you for staying with me tonight or for leaving it on while you slept. Either one is fine. If you want another, subscribe and it'll be here. Somewhere right now a dish is turning, and in what comes down from it there are stars nobody has ever examined, sitting inside the beam by accident, being listened to without anybody having chosen them. One of them will be the last one, eventually, or the first.